Hey everyone, welcome back to sorry, I think I need some light. Hey everyone, welcome back to Blockchain Week, Malaysia Blockchain Week. Yeah, welcome everyone back to Malaysia Blockchain Week. Need to do a little bit of introduction. So Blockchain Developer Week is part of Malaysian Blockchain Month, which consists of 6 weeks of educational content brought to you by Access Blockchain Association, along with its many partners, including, as you see right here, Bitcoin Malaysia, Blocklime, TopChain, IFKL, Grenade, AB Media, DeFi Singapore, and Imperium Universe. Okay. Let's jump into it. So in tonight's bootcamp, we actually have a really special guest. So this guest is actually Daniel Jin, who is going to show us how to get started quickly from Tezos. Welcome, Daniel. Hi, Daniel.
Hello.
You're on the stream right now.
Everyone.
So welcome, Daniel Jin. Thank you for being part of this event. We're really excited to learn from you in this bootcamp. And from here, I will be handing the floor over to you. Right.
Okay, thank you. Thank you very much. Hi, everyone. I'm Daniel from Nomadic Labs support team. I've been working there for approximately 1 year. Before that, I was a high-level judo player in the French team. I discovered Tezos 2 years ago and fell in love with this amazing technology. What I do at Nomadic Labs is helping daily users of Tezos to launch bakers, write and review smart contracts codes to solve any kind of issues they face. I also run a baker you can find at baking.finance. It is a community baker with low fees. We pay regular rewards and answer to any kind of questions regarding the Tezos blockchain. I'm really glad to be here with you today to present Tezos and its main tools and features to you. But first, before I start, please don't forget to follow Nomadic Labs on Twitter, LinkedIn, and visit our website. Okay, so the presentation will be divided in 3 parts. First, I will present my slides and detailed information provided. Secondly, I will perform a little demonstration of a smart contract and node deployment. And to finish, we will do a little Q&A. It will be the moment to ask any questions you have regarding Tezos. Let's introduce Tezos, the technology, costs, and performances. Tezos is a blockchain live since 2018. It addresses some of the key barriers to blockchain adoption. It enables smart contract creation with security measures thanks to formal verification. It is a means of mathematically verifying the correctness of a smart contract. It offers open participation to everyone thanks to a property called on-chain governance. Tez holders can vote for features and improvements propositions. The self-amendment property gives Tezos the ability to evolve every 3 months and become more scalable, more secure, and more user-friendly for our community. The liquid proof-of-stake consensus algorithm allows Tez holders to keep their coins with the possibility of delegating them to a baker. I mean, when someone holds Tez, he can use a Tezos wallet and perform a delegation operation on-chain. He stays the owner of the funds, but from a network point of view, he delegates his voting power to a baker. To thank delegators for their confidence, Baker reward them with new freshly minted Tez. Regarding smart contracts on the Tezos blockchain, they are either written directly or compiled down in Microsoft, the native smart contract language of Tezos. This smart contract language has been designed with respect to formal verification methods. Thus, it is possible to formally verify a smart contract before the deployment. It is a kind of security measure against hacks or bad behavior of the code. The governance of this chain is decentralized and involves the bakers. To vote and decide, the direction toward which the network should go. Tezos network has evolved 7 times so far, and with some key features such as, for example, gas costs reduction thanks to better optimization of computing for operation submission. We had sapling, a privacy feature enabling to perform shielded transfers within smart contracts. We had more recently a block time reduction by 2 brought by Granada amendment. We had reduction of the amendment process time and many other features. You can find an exhaustive description on the Tezos official documentation. Regarding the current and ongoing performance improvements, Granada has been adopted by the community in August 2021. One of the main concerns was about reducing the block time by 2. It is the first step towards scalability. Hangzhou, proposed this exact week, aims at providing new features such as views, the possibility of returning values in microSum, a table of contents to perform mathematical operations, etc. In Q1 2022 is planned Tenderbrake, a brand new consensus algorithm to bring a faster block finality. For example, the current one is 6. Tenderbrake aims at bringing it down to 2. It means that a block will be considered as final after 2 blocks have been produced. It is also scheduled to bring layer 2 solutions such as optimistic rollup to go to faster transactions and reach 1000 TPS. Regarding the performance in the future, many key values can be manipulated to enhance scalability along with technical features such as rollups and consensus algorithms. Block time and block size can be modified, but the most challenging part is to find the best trade-off when using different scalability tools in order to preserve the health of the chain. Here are the current performances of the Tezos network. For example, with the Granada amendment, we have 122 TPS for classical Tez transfers. We have 40 TPS for fungible tokens transfers and 124 TPS for FA2 transfers with batching. But please notice that they are subject to improvements with the future amendments. Now, let's talk about a key component of the Tezos blockchain, baking. Baking can be presented as the first native application of the Tezos blockchain. Bakers' infrastructure are responsible for the transactions verification and their broadcasting to the entire network. Bakers receive operations in a mempool. We can see a mempool as a big database which contains all pending transactions from users. Bakers validate them, they build block, they add operations to the blocks, and through the node they are connected to, they communicate the block to their peers. Becoming a baker requires a minimum hardware and a number of tokens which will be used as a security deposit when baking and endorsing new blocks. The minimum requirement in native coins to become a baker is 8,000 Tez. These are also associated with a voting power. This voting power is expressed when new features are proposed by users and developers to be adopted on-chain. But how does baking work? Baker is also called a delegate. It is chosen randomly depending on the number of roles they own. The delegate infrastructure is composed of 3 daemons. You have the baking daemon, who helps to create new blocks. You have the endorser daemon, which helps to validate created blocks. And you have the accuser daemon, which helps to monitor the network and ensure that nobody performs double baking or double endorsing. At each cycle, New baking and endorsing slots are assigned to bakers. You can notice also that delegates can be active or inactive depending on the amount of time they are on or offline. It helps to preserve the health of the chain. Now let's talk about clients and nodes. The Tezos client is a command line client and basic wallet. It can be used to interact with a Tezos node for querying, for example, its status or asking for information regarding the blockchain. The binary is the low-level tool to interact with a node. Every request or operation submission can be performed through the client binary. It also exists library and SDKs to integrate an application with the Tezos network. You also have public APIs to help users to explore, debug, and interact with the chain. As mentioned above, the Tezos official client allows any kind of interaction. It has been built by the same team that has developed the blockchain core. It is the most stable client, the most up-to-date, and it is, of course, compatible with all networks. Libraries have been built to enable users to interact with the Tezos blockchain in a smooth and effective way. You can find libraries for the most popular languages, such as JavaScript with Tezos, for example, Tezos for Python, Tezos G for Java, etc., etc. To quickly and simply access the Tezos network, you can rely on public APIs that have been built so far. Among the most popular ones, we have TZKT, Conseil, and TZStats. Okay, regarding nodes, as for the client I explained before, the official nodes binary allows users to launch nodes with their own specificities. The node is a main actor of the Tezos blockchain and has two functions: running a gossip network and updating the context. The context is the current state of the blockchain. The gossip network is where all Tezos nodes exchange blocks and operation with each other. FlexTesa is a Dockerized container to quickly launch a Tezos node in Sandbox. It can be useful, for example, to perform tests locally. Only the user of the sandbox sees what's happening on his light network. If you want to avoid, for example, managing your own infrastructure, launching your own nodes, you can rely on public nodes such as Giganodes or SmartPy. It will allow you to submit your operations and querying the blockchain on demand. Now, let's dive into one of the most interesting parts, the smart contract languages. A key feature of Tezos is that, which makes it different from other blockchain, is that it has its own a smart contract language. It is not like other chains that are EVM compatible. These are the main Tezos smart contract languages used by developers to build dApps. You have SmartPy. It is an intuitive language based on Python. You have Lego, which is a functional language. It reminds a little bit OCaml, the core language of the Tezos blockchain. You have most recently Archetype, which is a new domain-specific language with a focus on contract security. And you have, of course, Michelson, the native smart contract language supported by Tezos. It was inspired by Lisp and Forth. Okay, so this is a smart contract written in SmartPy. As you can see, it is quite similar to Python. Smart contract declaration is like creating a Python class. You have keywords sp.entry points that allow users to call functions that are in the contract. The storage of the contract is declared in the init function. And as you can see, this smart contract is a calculator. The storage contains a value which is 0, and you have entry points to modify the current storage. For example, you can call multiply to replace the current storage by the multiplication of x by y. You can do the same for add, for square roots, and factorial. On the left part on the slide, you can see that tests can be performed with the add test keywords. It helps verifying the correctness of the functions written. However, please note that they are not exhaustive. So you write tests, and it helps you to see if your smart contract behaves properly. But it's different from formal verification. This is a smart contract written in Lego. Lego has its own specificities. It is also a functional language as OCaml. It is closer to the concepts brought by Michelson with the storage, the list operations, etc. As you can see, the storage of the contracts is clearly declared with type storage. It uses a kind of switch case, like in Python, to execute the appropriate entry points. This exact smart contract is also a calculator. As you can see, there are 2 entry points that are add and sub, and with an initial int in the storage, you can either add a value called delta or subtract a value called delta. This is a smart contract written in archetype, the domain-specific language of Tezos. As you can see, variables can be declared very clearly with human-readable strings. For example, you can see clear addresses or clear timestamps that are after converted in bytecode. This smart contract is an escrow contract, and in this example, it helps to escrow a buyer's funds until conditions are met to perform the transaction toward the seller. As you can see, you have different states of the smart contract: aborted, confirmed, cancelled, and completed. And depending on the state of the smart contract, users can call certain functions. This is a smart contract written in Michelson. It is, as I told before, the native smart contract language of Tezos. It is a stack-based language. We can see 3 important parts that are parameter, storage. The storage is what stays in the memory of the contracts, and you have the code part. In the code part, each keyword, as you can see, unpair, swap, sub, for example, add or drop, consumes one or several values that are on top of the stack, and it finally changes or not the final storage of the contract. For example, if we go deeper into the parameter side, we can see 3 functions, because this smart contract is helps to store an int and perform operations on it, like increment the int, decrement the int, or reset the int to 0. The parameter is as a pair and with both sides, left and right. For example, if we wanted to call the reset function, we have to call the smart contract with the right side parameter. Let's see some useful tools such as wallets, explorers, faucets, and development tools available on Tezos. Okay, these are 4 of the main wallets used on Tezos. Temporal is one of the most used ones. It allows interacting with decentralized applications, to exchange Tez or tokens within its interface. It's very user-friendly and very used by the Tezos community. Umami is developed by Nomadic Labs. The purpose of this wallet is to integrate all the features of the current Tezos client. You also have Kukai, which is a web wallet, one of the first enabling batch operations. And you also have Ledger, which is compatible with software wallets and even compatible with Temple. And it is a security measure to store your private keys on a hardware wallet. Explorers are key. Explorers are key applications that help users to monitor addresses, track transactions that occur on the blockchain, see smart contract codes, monitor baking, etc. Among the most known explorers, you have TZ-Stats, you have TZKT, Better Call Dev, SmartPy Explorer. Faucets are available to get free Tez, for example, for testnet purposes, if you want to, for example, deploy smart contracts before doing it on the mainnet. So you get free Tez on a faucet and you perform your operations freely. Among the most known faucets, you have Magic Tezos faucets, testnet faucets, and testnet faucet bots. Regarding the development tools, when you write a smart contract, you have several possibilities. You can either use an IDE, like a SmartPy IDE, online IDE, or LIGO Smart Online IDE, or you can directly write your code on Emacs or on VS Code, for example. If you use a code editor, you have some extensions. For example, for Microsoft, you have an extension on IntelliJ. You have also one extension on Emacs, etc. An important tool has been developed by Matfish Solution is Solidity to LIGO transpiler. It helps people to transpile Solidity code into LIGO and for final purpose of deploying the smart contract on Tezos. Oh, sorry. Okay. Regarding the resources, here are useful links to build on the Tezos blockchain. As you can see, you have several technical and non-technical documentation. You have the official documentation on Tezos, the Tezos wiki, which explains the main concepts, and you also have the Tezos Agora, which helps to track the amendment, the current amendment, and how things are going on, and so on. All these websites will enable to learn, understand, and build applications on the Tezos blockchain. Okay, so now let's do a little demonstration of how we can deploy a smart contract using SmartPy IDE, online IDE. Okay, I hope you can see my screen. I am on the SmartPy IDE online, and I used the template calculator that I explained before. It takes the value 0 in initial storage, and we can perform operations on it. Okay, so let's introduce a little bit the SmartPy IDE. You have dark mode if you want. You have templates, which helps you to play little games, use FA1 token standard, FA2 token standard, and yeah, that's it, I think. When I press the run button, it does several things. Okay, so it is executing. Okay, so it's compiled down the code to Microsoft, and it executes the little tests here. For example, if I take the first line, 51, we called the multiply functions with 2 and 5. And as we can see, the storage, the initial storage that was 0 at the beginning, has been updated to 10 because we call the multiply function. The add function does the same. It takes two values, 2 and 5, and put the result in the current storage. So the storage is updated to 7, etc., etc. Now that the code is written, what we can do using the SmartPy IDE is deploying our smart contracts. So let's deploy our smart contracts by clicking on Deploy Microsoft Contracts. As you can see here, we have the current size of the storage, which is 2 bytes, and the current size of the code, the entire code, which is 774 bytes. If we want, we can also monitor the compilation, the Microsoft compilation of the contracts, which is here. And now we will deploy our Microsoft smart contracts directly with the SmartPy IDE. So let's click on Deploy Microsoft Smart Contracts. Okay, so we are on the contract origination interface. We need to choose the right network. Here we are on mainnet. We will do it, for example, on GrenadaNet. Okay, we need to connect our wallets. So I will connect Temple with my account 1, which has, okay, 10.374 Tez. And, okay, the amount of Tez I want to send to the smart contract, 0. I estimate the cost of deploying the smart contract, which is 0.001263 Tez. It's really cheap. And now, by clicking on Deploy Smart Contracts, I can deploy my contracts. I need to confirm by signing with my wallet. And okay, my contract has been originated successfully. And I will open the SmartPy Explorer to see my smart contracts storage and perform some operations on it. Okay, so let's browse the smart contracts, which is this one, KT1BT. Okay, as I can see, the storage is 0. Okay, and here I have the functions, I have the entry points of the smart contracts I deployed, this one. So I have the entry points, and I can directly call these entry points to modify the storage of the smart contract. So the smart contract storage is currently 0. I will call the add function, for example, with 10 and 20. I build the transaction parameter. An interesting property is that it also gives you the exact operation you need to write if you call your smart contract with Microsoft. Okay, so I built the transaction. I will connect my wallet. Okay, and now I will send the transaction. An interesting part also I wanted to show you is this part. For example, I could also directly call my smart contract for my Tezos client, and the exact operations would be this one. Okay, so I will do it with the interface. I send the transaction. So as a reminder, it was 10 plus 20 up. Okay, and I confirm the operation. Okay, the operation is sending, it is loading. Okay, so I will refresh the page. It's not updated yet. Up, it's not. Wait. I don't know if the transaction has been sent. I will do it again. I connect my wallet. Up, and I sent the transaction. Oh, please wait. Oh, okay. The previous operations has been taken into account, and I need to wait and update. Okay, it's not working now. I don't know why. Okay, it's okay now. I don't know why it takes a little bit more time, but now our storage is 30. So the addition of 10 and 20. I could also do the same for factorial, multiply, square, and square root, for example. Okay, so to finish, I will show you how you can deploy nodes using your Tezos client. I hope you can see my screen. I will verify. Okay, so I stop sharing and I share my terminal. Okay, background 2. Okay, so now I have my terminal. I think everyone can see it. So first thing we need to do before deploying a node is getting the Tezos repository locally. You can clone it from the official GitLab of Tezos. I also have it on my computer, so I will just access the repository. Okay, so now I'm in the Tezos repository. There are several files and executables and directories. The most important ones are this one, the Tezos node, which will help us to launch our node. We also have the Baker executable and also executable, accuser executable, etc., etc. The first thing we need to do to launch a node is to configure a repository. This repository will store our node identity, and it will also store the information, the blocks, the transactions of the blockchain. So first, we create a repository. So we configure a repository to store everything. So we will use the command to this node config init with, and we provide a directory name to store all these informations. Let's say Tezos Malaysia, for example. Okay, and we also give it a network. By default, it is mainnet, but let's say we want to launch our node on GranadaNet, for example. Okay, so our repository has been created. If we look at what is inside, okay, so we have the config file and version file. The config file is contained this information, and as you can see, we have the peers, the bootstrap peers. When we will launch our node, the first people our node will connect to is our SmartPy, GranadaNet node, Tezos Core, IL node, etc. Okay, so now we'll generate an identity for our node using the command Tezos node identity generate, and give it the exact repository where we want to store the identity of our node, Tezos Malaysia. Okay, so it is doing a little proof of work calcul to generate an identity for our node. Why a proof of work? It's because it is a security measure against DDoS, so that it prevents people from creating thousands and thousands of nodes. Okay, our identity has been generated, so our node has this identity. And now that everything is okay, as we can see, the identity JSON has been created. We can now launch our node. This node run with the exact repository where we want to store information. Tezos Malaysia, and we want to allow RPC's request to our node in localhost. Okay, and we launch our node. As we can see, the chain is on Granada.net, so the test net of Granada, and our node is connecting to peers. This one is the first identity peer that our node is connected to, and so on. We have this one, this one, this one, etc. He is connecting to plenty of nodes, and he is receiving blocks and information from these nodes and storing all this information in the Tezos Malaysia repository. Okay, so our node is loading. It's if we wanted to bootstrap our nodes, currently it would take, I think, few hours because a lot of things happen in the Granada testnet. But when we want to synchronize our node, we usually take snapshots. So a snapshot, it's like a big picture of the network as moment t. So it takes this big picture of the network, we load it to our node, and after we can do a quicker bootstrapping synchronization of our nodes. Okay, so as you can see, it is loading a lot because we receive a lot of information from other peers. And if we execute, for example, this command to see if our node is bootstrapped, of course it's not. It will, tell us, wait for the node to be bootstrapped before performing transactions. For example, if I wanted to send Tez from an address to another, I would have to wait for my node to be bootstrapped before doing it. Okay, so I can stop the node and also stop sharing my screen. Okay, perfect. Thank you for listening. I hope this presentation has been helpful for you, and I'm available if you have any question.
Hey, Daniel.
Hey, can you hear me?
Yeah.
Okay, sure, perfect.
So let's conclude your presentation.
Yes. Okay, so thank you everyone for listening me. I hope this presentation was helpful, and I hope you will have the right documentations and technical tools to build the dApps on Tezos.
If anyone has question, you can actually send in the question right now. Daniel, I think we give it 1 to 2 minutes. Like, let's see anyone have question.
Okay. Nobody claps, say hello. I have this one too. Nobody claps.
Yeah. Most of our viewers come from YouTube, which is interesting.
Okay. I can't see the questions from YouTube.
Yeah. I think there's no like send in question right now from
Okay.
yeah. That is cool. I think then this bring our session to a close today. Thank you, Daniel, for your time and effort to be part of the Blockchain Developer Week. Let me send in my. I'm really grateful to have you on this event. We are really grateful to have you today, and I think everyone who listened in basically learned a lot about Tezos, and I hope whoever listened in, you actually get started with your Tezos journey right after this. We have all the tools ready, we have everything ready. Really thankful for it. And yeah, that's all. That's conclude our Blockchain Developer Week, and we hope that you will use this bootcamp to save time and learn faster in your journey. Have a great weekend, everyone. Good night. Thank you, Daniel. Once
Thank
again.
you. Goodbye. Have a nice weekend.
All right, thank you everyone for joining in. This is the end of our podcast. We're grateful for everyone who actually tuned in for this one. There's no question for now. Yeah, so wait, let me add back Daniel a little bit. Daniel. So there's no question for now, but if there are questions, they will post it in the Tezos APAC group.
Yes, sure. I don't think I'm part of this group, but
It's okay. Yeah, I think we will add you into this group if you're not in yet. Really thankful about that. So thank you everyone. Tune in again. I say thank you so many times. Really grateful for everyone. Here's is the end of the podcast. Thank you.
thank you. Bye.